Good afternoon, everyone. Welcome to the seminar. Thank you for participating on the seminar in the Friday afternoon. I think we'll have quite a few participants already, and some of them still coming in. But I think we should get started. It's 5 minutes, more than 5 minutes past 3 o'clock. My name is Philip Liu. I'm a professor in the civil engineering, civil and environmental engineering departments at the National University of Singapore. It's my pleasure and honor to introduce today's seminar speakers, Mr. and Engineering Seng Chuan. Mr. Tan actually is NUS alums and holding 2 degrees, and one is a bachelor degree in civil engineering. Another degree is a master degree in building science. And Engineering Town is a registered professional engineers in Singapore in the area of civil engineering, environments, and the water. He is also registered professional engineers in many other countries, including Australia and several other Asian countries. And Mr. Tan has a long career in the area of sustainability, environmental engineering, and recently getting involved in research and practice in looking into the effects of climate changes, on the effects of climate change on the environments. Currently, Mr. Tan is the chairman and the managing director of Temposu Asian consulting firm, and which is a leading sustainability consultancy company in Asia, focusing on the development of United Nations Sustainability Development Goals. And so today, he's going to give a talk. The title of his talk is Climate Change, an Opportunity for Engineer. So I will let him get started, and he will spend roughly 30 minutes for his talk. And if you have any question while he's giving his presentation, please send your questions to the chat room. I will collect them and wait until the end of his presentation. Then I will ask on your behalf the questions. All right, so without further ado, Mr. Tan, the floor is yours.
Hi, Prof.
Hi, how are you?
Very good. Good afternoon, everybody. Just trying to share my screen. All right, can everybody see my screen?
Yes, we can see it.
I suppose okay, right?
Yes.
All right. Okay, so just and you for and I know there are students because so either ENS or definitely already started involved in the last 10 years. You will see the projects are getting more complicated. project require a group of professionals coming together to solve the problem. So it is not just only a single discipline, but you need to have integrations of different professionals to look at the design and the buildability aspects and the implementations and all of this. So first of all, I just like to spend a few minutes to talking about Cambodia Asia, because what we do here is slightly different. So we are a group of engineers, architects, scientists, panel, and the consultants together. So we are looking at the different aspects of the challenges, and we are not just only provide calculations or drawing, but we're trying to provide solutions. So what we focus on the natural resources stewardships as the natural resources start to depleting. So we're trying to see how can we conserve the natural resources in the longer year. Also enhance the environmental performance, right? And of course, if you see the circle over here, most of you all will be quite familiar, is the 17 Sustainable Development Goals. And our activities are trying to focus on the sustainable development for whatever things we do in the company. And our visions to be the leading sustainability consultant company in Asia. Why in Asia? Basically, we are looking at the Asia region is quite vulnerable because it's subject to disasters, is subject to a pandemic, the sea level rise due to the climate change, global warming, and all those things. So we are looking at Singapore. It's just a small. We do our part and we do our role, but a lot of markets are in the Asia regions. So our mission is to provide one-stop innovative solutions and integrated services to our client. So we combine science and engineering in our practice and focus on the UN SDG. And you will see we do have a few accreditations. We are also a certified training partner with GRI. GRI is a global reporting initiative. It's a global standard on sustainability reporting. Headquarters is in Netherlands. So we are one of the certified trainer. So we are also accredited greenhouse gas verifier for NEA. And what does it mean? Because Singapore started the carbon tax in last year. So there will be a reporting process, and we'll help the company to verify and make the reports to the government. And then, of course, we are the professional engineer board register, as well as a licensed assurance provider. So these are the for engineering students or engineering professional, you might not be so familiar with some of this, except the P board, you may be familiar. But as the project is getting more requirements, you need a different standards, especially international standards to comply with. All right. So our organizations, you will not be aligned, but we are basically is a circle. We look at the carbon and sustainability. So we're looking at the carbon advisory, assurance, greenhouse gas verification, green finance, and responsible investment. So those are the more on the management consulting aspect of work. And then we get into the urban resilient aspect. That will be more waste management, water resources management, energy, food. So those are the urban challenges you will face in our urban state. And more important thing is the environment and the ecology. So probably you've heard about more and more awareness, concern by the people, by the NGO. They are looking at how the development is going to impact the environment, and how do you monitoring, how do you live with the animals. So those are the a kind of area engineers most of the times are not aware of. But that is important when we plan for a project or any developments, whether it's an infrastructure project or whether it's a product itself. And of course, the famous climate change. Prime Minister in 2019 National Rally mentions about 100 billions on the coastal protection, and how engineer can play a role in this adaptations as well as mitigation aspect. So what is adaptations and what is the mitigation? Adaptation, that means, is when there's more on the intensity of rainwater concentrating in a certain area, you get a flood. How do you adapt to it? How do you design your drainage system? And how do you make sure the flooding will not affect your assets? And mitigation aspect is basically based on the global warming. Climate change is due to the global warming. You heard about Paris Agreement, you heard about 1.5 degree. So we try to reduce our emission. So simple way is, you heard about the EV, right? Electric government is trying to promote EV. So you reduce the emission. So that is one of the mitigating actions we are doing over in Singapore. So let me give you a perspective of the global trend. In fact, these situations on climate change, it is not just only recently happens. If you're looking at the whole trend, over here, this is a global risk reports in 2021, only this year. And the risks, they are assessing the risk and likelihood. If you look at 2010, most people were more concerned about the economic aspect. So there is a blue color, right? And then the risks by impact, the blue and the societal area. So, but throughout all this year, it shifted. It shifted to more environmental aspect, extreme weather, climate actions, you know. So, in fact, this year they have this infection disease that is the COVID, which locked us down for many months, right? So if you see more concerns about the extreme weather as well as the climate change. More on the regional context, this is, of course, the data is a little bit older. It's in 2015 under the study by ADB. If you look at the Asia Pacific region, we emit 40%. The rest of the world is 60%, right? And then if you're looking at China, India, Indonesia, where the populations is quite large, and of course they emit a lot more greenhouse gas in the Asia Pacific, which is 89%. And developing Asia share of the world electricity demand, by 2030 you're expecting 43%. And China and India is already occupying 64% of the Asia power consumption. So, but all these are driven by the economy development, right? So So if you read without any radical change, we will have a problem. We will have a share of 48% for the whole Asia compared with the whole world. So that is a problem. Right? And then that is also from ADB, climate actions. So the threat is what is the impact? How much cost with this climate change will affect us? And you're saying that 6 out of 10 nations will be affected by extreme weather. 18 million of Bangladeshi will be displaced by 1 meter rise in sea level by 2050. And then we're talking about climate change where 64 million of Asians will be pushed into the poverty, because you get into poverty because of the flooding affect the agriculture. And when there's food, you have a problem in food supply. You're going to get more people in the poverty. So this is where we need to be understand early. But all this problem, of course we understand, but what are the opportunities, right? So this is give you a perspective on the country in Asia, which country are more vulnerable. So looking at Myanmar, Philippines, Vietnam, Thailand, you probably heard about some sinking in land sinking. Even Singapore, why we take action so at this early stage, because Singapore is just only a very small country. So we are island state, and if sea level raised by 1 meter, I think most of us will have a problem finding the accommodation. If a big country, we can move into the outskirts, we can move into the inland area. But for Singapore, where can we move? So these are the kind of problem where engineers need to be aware of. So what are the actions that has been taken? Just give you a perspective on the global stages. In fact, in 1979, things already been discussed, and the serious discuss was in 2015 in Paris Agreement, and under COP21. Of course, if you heard a lot more Kyoto Protocol on carbon CDM, green development mechanism, but this CDM mechanism are not really working at this moment. So a lot of people are looking at end of this year, COP26. COP26 in Glasgow. So we're trying to find some solution set or some commitment by the various countries in terms of reducing the temperature to 1.5 degrees. At the same time, looking at the why CDM is not working, right? So a lot of expectations. We are looking at this COP26, in November this year. So you may look out for more informations about this and follow this, and you would have a better understanding about what is the effect, what is the impact. At the same time, we can understand what are the opportunity for engineers. So there's a lot of international initiative. There's a lot of policy making, such as ADB. Many years back, they already start not to fund coal power stations, right? And these are some of the action can be taken by the financial institutions, or by the World Bank, or even by the government when you put in more regulations into curbing the carbon emissions, but not much on the private sector. Private sector, a lot of us are looking at this is government problem. We can't help. We can't do anything. We can't help anything, right? So there are not much initiative coming up from private sector, but of course under the national or the state initiative, there's a lot of regulations where government trying to implement. For example, in Singapore, we have a zero waste master plan. All right. So we're trying to look at the circular economy, right? We're trying to having this carbon tax to the pollutive industry for them to reduce their emissions. All right. So these are the government expect, but I find that the private sector can do more. And in fact, if you look at during the in US, the Trump administration, Trump is against the climate change, right? But a lot of states they keep going on their driving the green initiative because it's for US is governed by the state and what the state wanted to do, so not central but by the central government. So US has led for a few years because there are not much initiative coming out. Yeah. Okay, so just give you a perspective of what Singapore is doing. Very early stage from 2008, we already have a committee on the sustainable development, and then 2009 we have a climate action plan. Then we have this national climate change strategy, and then we pledge at the Paris Agreement, and we have this carbon pricing. We have this sustainable bond grant scheme, and in fact, in the last year and this year, MAS also implemented all the listed company need to do their sustainability reporting annually. So that is more for provide a transparency to the investor, right? So a lot of a kind of initiative has been pushed out, and I think on the engineering committee, we need to understand what does it mean to me, and how can we participate in this all this scheme. Of course, very important. I think Minister Grace Fu has been very active in the Facebook promoting Singapore Green Plan. Singapore Green Plan is our strategy, is up to 2030 to look at how can we reduce our emissions. And we have a national pledge to the UN that we call NDC. It's a national determined contributions commitment. And what we're trying to do is to reduce the greenhouse gas emission intensity by 36% with 2005 as a baseline. So that is something what Singapore has committed, and you can see more aggressive initiative will be driven in the next few years. Maybe for people in the built environment industry will know that BCA also planned out quite a lot of green building, like super low energy building. That is another big initiative by BCA. So what is the Singapore target? Singapore target to peak is greenhouse gas emission at 65 million tons CO2 around 2030, and we're trying to halve the amount by 2050. And of course, a lot of countries are going into the net zero emissions. For example, China, I believe it's 2060. Japan, they are also committed to 2050 to be carbon neutral. Okay, so what are the mitigation strategy? I think we have a three-pronged strategy. We look at the transformations of industry. So you heard a lot of digitizations, industry transformation map. We're trying to transform our economy to make sure that our company are more efficient, are more productive, right? And then we're looking at adoptions of advanced low carbon technology that is more related to carbon capture, storage, and utilization. So this is also a lot of research has been done for those people in the university. Probably have done a lot, but frankly, in the industry, not many people are concerned about it because it's not going to impact the industry, all right? But that is not correct. We are trying every efforts to capture the carbon and then to see how to utilize it into a product itself. If you read some of the startup company, they are actually looking into certain product using the carbon as the material, right? So our strategy item 3 is more on the effective international collaborations. So, for example, on the climate action, regional power grid, communications. So there are quite a number of projects on the cross-border, and it can be on a regional basis. So in terms of transformations, I'll give you a bit more detail on the building. Just now I mentioned BCA wanted to have 80% green building by 2030, super low energy program. All these are a lot related to our work in engineering. Transportations, zero private vehicle growth. Of course, this is, but you will notice some of the new town, the road is getting narrower, right? So we are trying to reduce the number of lane or number of the vehicles, and I saw that in European country. Long time they already did that, and they are reducing their land transport, but mainly public transport. So a lot of road car cannot go in. It's only the buses can go in. So we have not get into that stage yet. But I think one of these days, I think if the population increase, we may need more land for residential than the road. All right. So 9 in 10 peak period journey. Okay, so I think you know that walk, cycle, and ride. This is from the LTA target by 2040, and these are EV by 2040. So on the industry side, we have this trying to improve the initial energy efficiency, right? So you may, I'm not sure, some of you know that NEA has, together with the IES, the Institution of Engineers Singapore, we have started a professional called EEOA, right? Is the Energy Efficient Opportunity Assessment Scheme. And that is trying to help the energy to identify where the opportunity they can reduce their energy consumptions. And this is a profession by itself. And I know those people who are involved in this scheme, they are very, very busy. And they are making quite a good money because there are not many people are able to register. It's a quite stringent condition, but I'm sure the mechanical or electrical engineers are able to get into registration in this scheme. right? This is more focused on industry. System-based solutions, low carbon technology, there are many new startups, they are working on this. And so in terms of waste and water, we're looking at circular economy, zero waste roadmap, if we refer to, there are many initiatives over here. Also to the water, right? On the water aspect, trying to reduce the energy consumption for the membrane. I think PUB is working on some pilot plant some years back. Of course, the household, you have the green label scheme, and product need to be registered with Singapore Environment Council on a green label. You will look at how many ticks and all those things. So there are many initiatives. It's just that how engineers can get into some of these areas, how they can understand, oh, even now we have a lot of grants for them to convert. So you can tap on some of these grants by SkillsFuture and learn other skill set, and probably you are able to find much more opportunity. So of course, on just I mentioned on the adoptions and advanced low carbon technology, this carbon capture, storage, and utilizations is a lot more on research, but there's quite a number of products already commercialized. Low carbon hydrogens, we are looking at EV, right? EV is still not very clean, not a zero carbon emission yet. EV still have some problem, but it's still cleaner than the normal fuel, right? But I think hydrogen is one of the good solutions, but it's not popular at this moment. But because of the cost as well as the technology, still need some improvement. We also work with a lot of collaborations in the within the ASEAN. If you follow some of the ASEAN summits, then you can pick up some of the initiative among the ASEAN government has agreed upon. Adaptation strategy, coastal protections, you probably heard a lot, and PUB has commissioned the first East Coast coastal protection study to a consulting firm. And beside coastal protection, we do have a biodiversity, trying to be more green. And maybe you will understand that there's MPark has published a biodiversity impact guideline this year. And of course, building an infrastructure, BCA has their roadmap, as well as a public health, food security network. There are many others. So this is the kind of area where engineers are able to participate. You will see quite a number of areas, but it just needs to be focused, because discipline-based, I find that is in the present economy, where the project getting more complicated, it's not sufficient. You just doing your own discipline. You need to understand the sector better, and then you need to integrate with other professions. Then you are able to contribute to that sector. All right. So, of course, the percentage here is based on the global study. Bringing back to the Asia Pacific regions, you can see there are quite a lot of jobs. This is done by if I'm not wrong, this is a recent study done by the more on the renewable energy. I believe is International Renewable Energy Agency. So they done this study looking at the number of jobs on energy aspect, right, related to energy. So energy transmission, distribution, solar, smart city requirements, climate mitigation and adaptations. There are already 14.2 million jobs. But of course, this is global. And of course, this is also energy sector. If from 2 degrees we cut down to 1.5, we are able to reduce the almost 37 gigatons of carbon per year. That is also more on energy sector. A lot of emissions are related to energy. And just give you something on the food and agriculture area, and probably you heard a lot more on the urban farming. There's a lot of IoT technology you apply to this urban farming, and that is also engineering. It's not so much on agriculture, but you apply engineering concept into the urban farming, as well as hydroponic systems, integrating water and energy and waste together. Of course, the bigger projects are like the adaptation aspect on the Bukit Timah diversions canal is solutions to the flood protections. Of course, you heard about Tekong recently. The Straits Times just published polder developments in Tekong, and we're not only increasing our land, we protect our coastal. At the same time, we're creating land. At the same time, we're creating water catchment. And land can be of many uses. And for future, there are many others, this kind of work around Singapore. So there's a lot of awareness, not only awareness, a lot of actions already being taken by many countries. And the opportunities are there. So this is where not only engineer has to work with other professions, the academia, and also the individual, because individual is a social aspect of need to be taken care of, and that is very powerful, right? So when we talk about sustainability, we always talk about ESG. ES is the environmental, economy, social, and governance. All right, so thank you very much for your attention. Thank you.
Thank you very much, Mr. Tan. I think the floor actually is open for questions. As I mentioned before, you can send in your question in to, I think there is a Q&A board, is that true? Or you can send in the chat room, and then I can collect them and ask a question. Actually, I already have a couple questions for Mr. Tan. These are rather big questions, and I will do the best I can to translate it. Basically, I think one question is about the relationship between how to mitigate the negative impacts of climate change versus the economic growth. So some of the policies and plans you mentioned seem to be primarily aiming at more developed economy or the countries in general. So in the Asia region, in particular, there are many countries that still can be classified as either underdeveloped or developing countries? And what's your thoughts or your opinions on how do we either help them in some way, and at the same time, will actually help the overall environments as well? So it's a very big question.
Yeah, I don't know whether I can answer that or not, but I try, right? So actually, many years back, ADB has started this initiative. They have putting a lot of funding to all these countries, and this funding, there is a requirements. You must be energy efficient, you must be low carbon for all your developments. And I've been participating one of this. We have studied 16 cities. I think it's 15 cities in Southeast Asia. And then we're looking at their whole economy, the culture, and then looking at the vulnerability as well, and also their capacity. So some of this kind of study will go into the government policy. And of course, it will go to some of these financial institutions. Say, for example, there is a kind of projects by a funding by European nations. Actually, the fund is only building capacity in some of these developing countries. So building capacity, that means they might not have the capability to do it by themselves. So they need kind of organizations to help them to build capacity, create awareness, and all these are funded by the financial institutions. So there are many funds around. Of course, there are some private funds that are looking at more return. But on the big picture, ADB, World Bank, IFC, they all have some supports to the developing country for them to get into more green, more sustainable developments.
Okay, all right, thank you. I have a couple more questions. One is very, very specific questions. This person asks that, do you feel that there is a more potential for one to become an AE in pressure vessels? So the very specific. Or do you feel that there is a more potential to pursue other specialties, specialties, I guess, as a PE? So that's a very, very specific question. Right?
Okay.
Then I would like to add some to make it more broader. You can answer the first, then expand it to maybe advise some of the undergrad students or the newly graduates. What do they need to do or prepare themselves in terms of training or educations, or even maybe as a faculty member, we would like to get some information from people like you in the industry. Then what kind of courses or what kind of training should we provide the future engineers in this area? That's a very broad, but the first one is a very specific. Can you answer that one first?
I suppose the person mentions about AE is the approved engineers for the pressure vessel inspection,
yes.
Right? And you have the mechanical PE. Basically, you're only looking at the building services and submissions of drawing to PCA for some of the building development. So getting into AE, I think it's not difficult if you have the knowledge on the lifting equipment, pressure vessel, because your base on mechanical is there already. And of course, you need to attend some training for you to get into the AE. AE, the requirement is you must be a PE first. So then you can be an AE. Otherwise, you cannot go direct, right? So once you obtain a certain experience, for example, AE is more related to safety aspect and industrial safety aspect, right? For example, steam piping, pressure vessels, and all this inspection work. In fact, there's a lot of opportunity. One of my friends is so busy, I cannot locate him because every time you call him, he's at the site doing all this inspection. And I know my colleagues, one of my colleagues, many years we worked together, and he's from MOM, all right? So he came up from MOM. He has the knowledge on the regulatory requirement. He's a mechanical, so he just take the qualifications, and he's very busy. I suppose he's doing very well throughout all these at least 20 to 30 years. So I would say first get into the fundamental. You need to get a PE first, and I'll give you another a kind of opportunity you may have because IES also register chartered engineer. So chartered engineer is more on a sector base, and this was started probably about 10 years ago, and now we're trying to get into actions and trying to make that into a requirements. So this is another opportunity. If you are interested, you are able to also approach IES on some of this registration. Just now I mentioned about the EEOA, the Energy Efficiency Opportunity Assessor. So, and even some SCEM, Singapore Energy Manager. So those are the additional qualifications. And if you can't get into the PE route, we can go into the chartered engineer route. So we provide more opportunity.
Okay, so that's the first question. Answer to the first question. The second question, I think, is much more broader questions. It's thinking back. I think you and I more or less in the same generation. Well, I don't know, but the point is that so for the young engineers or to be engineer, what kind of different education or training should we provide to these youngsters? Then in the good old days we learn a different way, and now everything changes. And so, what is your quick suggestions?
Okay, so if you see one of my slide over there, you see the trenching of shifting kind of from the economic base into more environmental base. More people are going into green space, and green space, you need integration, you not just only engineering. So last time what we had done is we study civil, we study structure design, we study hydrodynamic, we study ecology. All these are very single discipline. But now what you need is integrating all of this together and make it how to integrate. So integration is one of the very important area for the younger generation to study. Not just thinking about I just doing the civil engineering, but when you do a civil engineering work, you need to understand what others are doing. So I also understand NUS has started a new program together with the SDE, School of Design and Environment, and this is one of the promising program for the younger generation, because the whole program provide different approach, and not only engineering but including some social sciences into the program itself. Say, for example, on coastal protection. Coastal protection is not just only engineering. not only just civil engineering. Of course, it's heavy on civil engineering, but you do require some other area, for example, like environmental aspect. How do you design? How do you orientate your infrastructure? How do you study the wave? If you want to put a bund wall in front to protect the water from coming in, and all those things. So the whole concept must be clear. And this is different from the building design. If a civil structure PE doing building, definitely cannot do coastal protection because the whole concepts are different, right? So I believe that is the future. We need to have a mindset of integrations of different discipline and professional together, and looking at the bigger picture rather than looking at code of practice alone.
Right, I agree, and I think that it's my pleasure actually to report to you that NUS has started a new movement into promote more interdisciplinary type of curriculum for undergraduate students, and not just in engineering, actually it's in the entire university. And basically, in FOE, for example, or the future FOE plus the SDE college, and so that students are taking many courses as a common curriculums in the first year or so. And not only that, what this will enable them to get educated in much broader area or different areas, and also that will allow them to a double major, for example, in two subject area could be very different. Could be combination of business and engineering, for instance. And so I think would be really dramatic change if we can actually require all the engineering students to take a biology. Can you imagine that, right? Because you mentioned that for the future, when you design the coastal environments, you need to know biology, you need to know ecology, right? So all the young engineers are supposed to be much more knowledgeable in those general areas than we are actually. Okay, one more. There's another question, a little more specific. Questions is followed. Do you think floating cities are an alternative to land reclamations in terms of a climate change, its effects on coastal life and environments in general? So I guess we're thinking about the coastal protection and the future growth, economical growth. What is the direction should we go in Singapore where land mass is very limited?
Of course, you will see Netherlands. They do have a coastal town, I believe. You see they're using the floating technology to house some of the residents over there, and of course Singapore to a certain extent. And we do have a limitations of our seafront area not big. And if you go to East Coast, maybe the seafood center, you will see the whole road, all is surrounded by all the ships. So our economy depends on also the ship coming in and going out. So it's a big challenge for us to say, applying one kind of solutions to Singapore. Singapore probably need different solutions and at a different area, because we are just so small. We don't have sufficient land to design for one type of solutions. So of course, maybe when you talk about floating city, some of these islands, we can try it out. And because island is surrounded, and we can have a floating city all around, and it's a viable solutions, but you just need to apply to the right locations.
Yeah, I guess you're absolutely right. I mean, Singapore faces many, in that respect, facing multiple challenges. One is that land mass is relatively small. You don't have anywhere to retreat to.
Yeah,
Then also the water space also is limited. You push into the navigation channel, as you said, very quickly. In fact, you push into the international water very quickly. So I think that something like a floating cities idea, probably smaller scale floating city,
yeah,
and that's more feasible to think about it, and maybe couple that was a fish farming, and rather than people living there, but can be make into multi-usage type of facility, is something definitely can be considered.
yeah, yeah. I think, Prof, you have a good idea. Actually, we need to be self-sustained. So if we build in a floating city, it must be self-sustained. So you don't need to have too much traveling.
Yeah.
So if you can have a multiple kind of whether it's industry or residential, a cluster by itself, I think that is still possible. And probably
Yep.
some pilot project can be done.
Yeah, I must bring this up though. We have to consider no matter what kind of coastal structure, either it is connect to the land or offshore or even floating, you must consider the environmental impacts, right? I think people have seen some of these amazing facility like in Dubai, they have all this island, artificial island.
Yeah,
Either it's like palm trees or the it's like a globe,
yeah,
and but the environmental impacts of building those infrastructures are tremendous, especially in that area. The circulations, ocean circulation is not that strong.
yeah,
So anyway, so when we think about, as you said, when we think about the solution, that we have to think about what is the impact of the solution so that solution will not become a problem eventually.
yes, yes,
So I think that's something that
yeah.
really have to think about.
In fact, our floating solar panel.
Yes,
Uh,
they have some issue, right? Yeah.
yeah. So these are the considerations. So this is just an example of some. It's not just only engineering, but there's a lot of considerations, and this is where you need to be industry based.
Yeah.
Yes.
Yes. Let's see. I don't see any more questions. And okay, so actually it's 5 minutes past 4 o'clock. If I don't hear any more questions, then I would just like to thank Mr. Engineer Tan for excellent presentations and lovely discussions on the various topics. And I think we all benefit by your engagement here. And also would like to thank the audience for for your participations. And so this will conclude our seminar today. Thank you very much, everybody.
Thank you, Prof, and
Have
thanks.
a good weekend.
Yeah.